Well, hi everyone. Today I will be talking about solutions from today Atcoder Beginner Contest without problem F, cause I didn't manage to solve it, and I will be talking about problem G. So let's start probably. I hope that you are able to see it. Okay. So well, the first problem was just implementation problem. You were given a string and you wanted to write the longest suffix which does not contain dot. So maybe I'll just show you a code how I have done that. Yeah, so I read the string, I reversed it because it was easiest for me to just reverse the string, and then, well, B is my answer, and I was adding characters to it until I found a dot. Then, well, I'm adding characters to B from the end because I reversed my C, so I was just reversing B and then I'm writing B to output. So that's not really interesting, that's just implementation problem. So, well, B is implementation too. Well, in problem B we were just given a grid which was, on start it was like white, all of the grid was white, and then we wanted to do the following operation n times. If the current cell is white, then paint it black and change our direction of moving clockwise, and if our cell is black, then change our cell to white and change our direction of moving counterclockwise, and we are starting going upwards, right? Our direction is up. So, well, they are, and also the grid is a torus. So if we are going like out of grid, so let's say, wait, maybe I will just write it. So, well, if you are going like this, then, well, we are like appearing at the beginning of our grid, right? Well, we can just add modulo, you know, so I will show you a code, but I think everyone solved it, but I can show my code. Oh. So I'm creating a board which is initially all zeros, and as I wrote here, 0 is white and 1 is black. I am numbering this board from 0 because, well, modulo works better when you are numbering everything from 0. And I have my possible moves. So, well, first move is going going down. So then my y axis changes by 1 and, well, my x axis doesn't change. The second direction is going left, then only my x coordinate is getting smaller by 1. Third move is going up, so then only my y coordinate gets smaller by 1, and my fourth possible move is, well, going right by 1, right? So, well, how did I implement it? Well, I'm checking if my actual well, if my actual cell is white, then I am changing it to black, and I am changing my direction by 1, because I ordered these dimensions to be, well, clockwise, right? My going my going down is like my first direction, then going left is clockwise to it, going up is clockwise to going left, and going right is clockwise to going up. So I like this implementation of mine. And well, uh, changing my direction by 19 degrees clockwise is just, well, changing it by 1 in this vector, right? And I'm taking it modulo 4 because, well, when I am facing right, then I want to be facing down. So I will be going from third cell of my vector to 0th. And then why am I having +3 here? Because on this vector, giving +3 is the same as -1. Right? For this one, +3 will point here, so it's -1. From this one, +3 will point like here, here, here. So it's -1 again, and you know that's how it works. And then I am just changing my coordinates, because, well, I am changing my I'm changing my first coordinate by moves from direction from first. So, well, here I am keeping my change of first coordinate, and here I am changing keeping my change of the second coordinate, right? And also, because it's a torus, well, I want to somehow, when I am going out of the board, appear on the other side of the board. Well, that's just how modulo works. So I just added modulo. And then I am just writing board. So that was also not very interesting problem. So let's go to problem C. Well, in problem C we are getting a bus and we don't know how much passengers it has in the start. And then we have n events, and in one event there are, well, the number of passengers in the bus changes, right? It can get bigger, let's say bigger by 3 as it's in this example, or it can get smaller, right? -5, it's like 5 passengers are going out of the bus, and +7 is like 7 passengers are going into the bus. And now we want to say, well, we don't know, but assuming that we will pick the first value to be as optimal as possible, our initial value of passengers, what is the minimum possible current number of passengers after all these events? So, well, in this task there is only one easy observation. So, well, when we will look, let me write the example test. So, when we will look at the number of passengers after some events, some prefix of events, right? Then we know that, let's say after 2 events, 2 passengers, because 3 passengers have gotten into the bus and 5 passengers, like, they left the bus. So we know that in total there are 2 less passengers than they were before those events, right? And, well, I say that it's sufficient to only look at the smallest such prefix. Because if we look at some prefix, let's say this prefix, well, it's greater than 0, right? So we know that, well, we can have any amount of passengers in the start, because this prefix doesn't destroy anything. But when we have like this prefix, we know that 2 passengers got out of the bus in this prefix. I know that I need at least 2 passengers in the start, right? So when I will find this minimum prefix, so let's say I will know that after some amount of events, 5 passengers got out of the bus. I know that my initial amount of passengers needs to be at least 5. Right? And also, they are not asking me about my my minimal initial amount of passengers. They are asking me about minimal current amount of passengers. So my answer will just be our minimal starting plus minimum plus sum of events. Right? Because, well, in this example, we have our minimal starting, our minimal prefix is -2. Right? Every other prefix is like greater than 0. So we know that our starting amount of passengers is at least 2. So after all the events, well, our amount of passengers will be 2 plus 3 minus 5 plus 7 minus 4. So it will be 3. So the answer in the first example, as you see, is 3. So let's go. Well, implementation here wasn't like a problem, so I won't show it. So let's go to problem D. Well, problem D was like, I think, most implementation heavy in this contest. So in problem D we are once again given a grid. So let me write this grid that we have here. It's 5 by 5. No, it's not. And well, in some cells of the grid we are given obstacles. So here it will be in this cell. This cell, this cell, and this cell. So, and we are given 2 players and their starting positions, like you see here are the players on grid. So here and here. And in one operation you can shake our grid. So you can make both players go left, or both players go up, or both players go right, maybe I won't write it, or both players can go down. But if my players would be, let's say, like this, then only this player would go up, right? That's like the main thing of this task. Only the player moves in the direction that we say them to move, only when he can. So, well, this player can go up, but this player can't go up. And the other case is that, well, when we say them to go left, this player can go left, but this one won't go left because he would go out of the grid. So now we want to say the minimal number of those moves, right? In one move we are saying them the direction that they need to move, such that they will end up on one cell of the grid. Or we need to say that it's impossible. So in this example it would be 2, because we are saying them that, well, go left, this one will go left and this one can't go left, and then go up, this one will be on this and will go up, and this one, well, he won't go up because he can't, right? So yeah, that's like the statement of our task. So, well, when you will think about some maybe greedies or something like this, well, you won't get anything. In this type of task, it's like hard to see what is the optimal path. So what you need to check always in this type of task is what are the constraints. And as you see, n is really small. So our side of the grid is up to 60. So well, n to the power of 4 would be a really good complexity for us, right? Because 60 to the power of 4 is, well, really good. Usually in task when n is up to 100, you can do like n to the power of 4, and here it's much smaller than 100. So, well, let's try doing some BFS. So, well, in my BFS, I will be one vertex of my graph in BFS would keep like 4 values. It would be it would be coordinates of the first player and coordinates of the second player. And then, well, we would try to, from every node, we would try to generate all the edges, right? We have 4 possible edges, and for every edge, we are looking how are these 2 values changing, right? And then we are just doing BFS on this graph, standard BFS. So, let me show you a code, because, well, in this task the code was the important part, I think. But I don't see any questions, but let me show you a code of mine. So what I am doing here is, well, I'm keeping those 2 pairs that will mean what are the starting coordinates of our players. And I am also keeping this, well, it's a Polish word, so that's not good, but, well, I'm keeping those 2-dimensional array, and when it's 0 means no obstacle, and 1 means obstacle, right? And now, when there is obstacle, I am saying in this array that, well, there is an obstacle. And also, if the first player, if I haven't found the first player yet, then I am setting it my coordinates. And if I found first player already, then I'm setting coordinates to the second player. So here is this BFS. I am not generating graph, I am just doing BFS, and I'm generating my graph while doing the BFS. So here I'm keeping those distances. It's like 4-dimensional array, right? It's an array it's like distance from I1, J1, I2, J2, right? So I'm keeping, well, minimal number of moves to make the first player be on those coordinates and the second player on those coordinates. I'm saying that after 0 moves, well, those are the coordinates of players, right? And also I am keeping my queue of tuples, because, well, tuples are most comfortable for me. And I'm saying that, well, on the start on my queue there are only, well, the only possible placement of players on the start are, well, the starting placement. And also I'm keeping this tricky vector of pairs that, well, those are, as you will see, those are only possible changements of like our coordinates, right? Okay. So I am getting this is structural binding, and I really, well, I can recommend it to you. It's really comfortable. I'm getting my actual coordinates from my queue. I am popping it. If they are the same, then, well, I have found my distance, because that's just how BFS works. And then I'm generating my graph. So I'm iterating through all directions, and I have 2 possibilities. In one of the possibilities, my second, so my x, so my like column doesn't change, and in the second case, my row doesn't change. So if my column doesn't change, I am checking if, well, I'm only changing my row if I can, right? So I am only changing if it's not out of the board, and if it doesn't have the obstacle, then I am changing it. The same for the second coordinate. And I'm doing the same for when I'm doing the same thing when the first coordinate doesn't change and the second coordinate does change. Then I'm checking if I didn't visit my new vertex. If I didn't visit my new vertex before, well, then I am visiting it and putting it on my queue. So yeah, that's just how I wrote it. So I still don't see any questions. So let's go to another task. Problem E. So problem E is very standard. So let's talk about it. Okay. Well, in problem E we are given a sequence with a number D. So let me write you. Yeah, so we are given a sequence with number D. This is our D. Someone asked the question, how are you printing the answer in question C? Let me show you. Well, as I was saying before, in question C, well, I am just looking for the minimal prefix, and my answer is my sum plus the because our lowest initial value is minus minimal prefix, right? Because if I know that, let's say, after some events, let's say 3 passengers got out of the bus, then I know that my value needs to be at least 3, right? Because minus 3 is 3 passengers getting out of the bus, and, well, my lowest possible value after all the events is sum of the events. So let's say 2 passengers got out of the bus after all the events, plus my lowest initial value. So I hope you understand. But also I was explaining it more before, so the stream will be saved, so you can see it after the end of the stream. So let's go back to the problem E. In problem E we are given this. In problem E we are given this sequence, and, well, we want to check the longest subsequent of this sequence, such that the absolute difference between any two adjacent elements of this subsequence is at most D. So, well, in this sequence we see 3, 1, 2. I hope everyone knows. Subsequence is like some subset of elements of this array. So you can choose any subset, but the order can't change. So we see that in this subsequence, well, I will try to write it. In this subsequence that I marked, well, maybe I will give you it with color, right? Because it will be more beautiful. So in this subsequence that I marked, well, absolute value of 3 minus 1 is equal to 2. Absolute value of 1 minus 2 is equal to 1. Oh, sorry, I start writing fast. Absolute value of 3 minus 1 is equal to 2. and absolute value of 1 minus 2 is equal to 1. And, well, we see that both those values are smaller than our given d, so 2. So, well, this is the good subsequence. But why can't we take our whole array as our subsequence? Well, if we would take our whole array as our subsequence, then absolute value of 3 minus 5 is 2. So that's good for us, right? We can have it. But our absolute value of 5 minus 1, so those two adjacent elements, is 4. So it's much bigger than d. So we can take it. So now that we understand the solution, maybe I will just go through it. Well, we will be using dynamic programming. When you have some problem, when you want to count the longest subsequence of our sequence, such that when you have a problem, when you want to count the longest subsequence of our sequence, such that well, wait, how to say it? I'm sorry, but my English. Well, if you want to count the length of the longest subsequence, such that its adjacent elements, they have some constraints, right? So here we know that they can't be too far. Those two adjacent elements, they can't be too far on the number line, right? They absolute value can't be too big. So if you have problem like this, let's say, I don't know, you could also have something like let's say the sum of our adjacent elements can't be too big, or it can be too small, but something like the biggest subsequence and two adjacent elements need to satisfy something. Then you want to do dynamic programming. And in those type of problems, the dynamic programming will always or almost always look like this. Dynamic programming from index E looks like this. Length of longest subsequence such that greatest index in this subsequence is I. And now, when we are in our I, we want to think about, well, what j before could be our, last element before I in our subsequence. So we know that, well, a from I minus a from j must be smaller than d. And I say that it will be true only for j's such that a from I plus d, such that j is between ai plus d and ai minus d. It's like, well, definition from absolute value, right? And when we have something like this, so we know if we would like to right now do it in like n squared, then we could just write a simple dp. dp from I, oh, sorry for writing so fast. dp from I is equal to maximum over all j's smaller than I, and also aj must be on this interval that I wrote. Right? Those are our conditions. When you have dp, you want to think about those conditions that I wrote. This is really helpful to you. Of dp j. So we are taking the subsequence that j had, and we are adding our elements. So we are adding 1. So this gives us solution in complexity n squared. Well, it's good solution, but it's too slow. So now, well, we would like to use the segment trees. We know that if we'll go, if we will go in our array, if we'll calculate our DPs from left to right, the first condition will always be satisfied. Because only DPs that we calculated to now will have the smaller j than our I, right? That's condition that calculating our DP from left to right gives us. But now we would like to somehow get maximums from this interval that I wrote, right? We would like to calculate the maximums on those interval of values. So we will just do segment trees over values. When we calculate all DPs on our prefix of our array, we will do the segment trees over values. So I will say that my segment tree from AI is equal to DP of I, right? And well, then calculating our DP would just be taking some range maximum from our segment tree. So in our segment tree we have like this point updates when we want to maximize on point. Because well, we can have many same AIs, right? So we want to maximize on point and take maximum on our subsequence. But the most important thing in this task is, well, when you have DP, it's really important to write something like this to yourself. So let me show you a code. The code is looking like this. Here, well, everything here is just my implementation of segment tree. And well, this is just our DP. As I said, my DP is equal to the query between my value minus d and my value plus d. To don't get overflows, I am saying that, well, if my value plus d is greater than the maximum value in this array, then, well, I don't need to check it. The same, if my value minus d is smaller than 1, then, well, I don't need to check it. So I am always maximizing with 1 and minimizing with maximum. And also I am, well, adding my element to this subsequence. And then I am saying that now I have some subsequence ending with value tab from I. And well, the length of the sequence is dp from I. And then I'm, well, counting best dp, maximal dp. So I hope everyone understands this. Oh, the difficulties are already there, as you see. So now I will go through problem G. Well, I didn't have accept on a node contest, but I know how to solve it. I just have some bug and I didn't manage to debug it. So in this problem, we are given an array. Let's say this array. Oh, maybe I will write it to you. So we are given this array. And well, then we are given many questions. We need to answer those questions online, right? So, in one question we are given some interval of our array, let's say this interval, and the number x. And we want to sum all the elements on this interval such that their value is not exceeding x, right? So if our x would be equal to 3, we would sum this value, this value, this value, and this value. Because they're, well, 4 is greater than x. And our answer would be 4. So, well, I will say my solution. It's in complexity log squared for every query. So we'll be doing segment tree once again. But right now, in every node of this segment tree, I will be keeping sorted set. This will be a set of pairs. So let's say that I have my node of segment tree such that this node it's like responsible for, let's say, 0, 2, 2, 4, right? Those are the values. So what I'll be keeping on my sorted set will be prefix sums over sorted. It will be prefix sums over sorted, this sorted set, right? So I'll be keeping pairs like this: 0 and sum over this prefix is 0. I'll be keeping 2 and sum over this prefix is 2. I'll be keeping 2 because, well, it's the maximal value of this prefix, and the sum of this prefix is 4. And I'll be keeping 4, and, well, the sum on this prefix, well, it is 4. So right now, it's really easy to calculate this sorted sets for every node in our segment tree in like the complexity n times log. So now when I am asking a query to my segment tree, well, I have some my basis vertices, right? That's how our segment tree works. So now for every one of those vertices, I will be just doing bin search. When I will have my x equal to 3, I will find the last pair such that the first element of this pair is at most x. And I will be just adding to my answer the second element of this pair, right? Because this is the prefix sum of the longest such prefix such that, well, all the elements on this prefix are not exceeding. So let me show you my code. Maybe some of you will find my bug, because I couldn't find it. So here's my code. Here I am, well, to every like node of base of my segment tree, I am adding my, I know that the only element in this base is, well, the element of my array. And then what I am doing is, well, I am creating the sorted vector of all the values that my segment tree node is responsible for, and then I am creating this set. First element of this pair is maximum on prefix, and the second element is sum on prefix. And then, well, in my query I am doing what I said to you. I am, well, adding to... I am looking for the first index. I am looking for the first index such that the first value is greater than x, and then if it exists, I am taking the previous index. Because if I have taken the first greater, then the previous index would be last at most, right? And I am adding those to my answer, and I am, yeah, writing it. So maybe I will try to read the editorial to problem F, and oh, there is no. Well, I would like to see the editorial to problem F to be able to say it to you. So I will try to look it, and yeah, maybe I could tell it to you. How does he solve it? Oh. Okay, I know the solution to this problem. It's really bad that I didn't solve it because I was thinking about it on contest. So, yeah, I can tell you the solution of problem if 2. So in this problem we are giving we are giving up to 1000 really big numbers, right? Numbers such that their length is up to 1000, and we want to count the number of triples a, j, k, such that the such that the first two numbers multiplied by each other are equal to the third number. So what we'll be doing in these problems is we'll be hashing those numbers. We can see that, let's say we pick some modulo. Let's say we pick some modulo, let's say equal to 10 to the power of 9 plus 7. And then I say that, well, if this is equal to, if this is sufficient, well, wait. If this is true, if this is true, then if we will take every one of those numbers modulo, so if we'll take ai modulo multiplied by aj modulo, it will be equal to ak modulo. Also, we need to take another modulo here, right? Cause, well, that's just how modulo works. But there may be some unwanted pairs, cause, well, if let's say I would pick my modulo equal to 2, and I would have, let's say, elements 1, 3, and 1, then, well, I would say that 1 times 3 is equal to 1, and that's not true. So, but the organizers of the contest, they don't know which modulo would you pick. So if you would pick some 2 random prime modulos, big prime modulos, and change every one of those numbers to, if you would pick some big prime modulo and change every one of those numbers to this, well, you would just change every ai to ai modulo our mod. Then you could just, well, now you have like smaller numbers. You would like your modulo to be like probably up to 10 to the power of 18. And now you have the same problem, but on really small numbers, right? So the idea here is that, well, we will just iterate over these two values and take the k values from some map. So I can try to write it to you, right? Let me write this to you. So let me do some live coding. Or maybe no. Maybe no. I know, but does anybody have any questions? So what we are doing basically here, we are like saying that, well, if this works normally, no, if cause someone asked, shouldn't the modulo be larger than largest AI? Well, it's the case when you hash numbers, when you want to check if two numbers are the same, and now, well, you don't want to check this. Or wait, does well, it's a good point, but this one won't work if the organizers would know which modulo would you pick, and they would pick some number that is the multiple of your modulo, then it's really bad for you. But the organizers picked, let's say, 50 random tests or 50 tests, and they don't know what modulo would you pick. So if you will pick some big random modulo, then none of the numbers will be a multiple of your modulo, so everything will work. So does anybody have any questions? But yeah, that's a good insight, what you wrote. So, okay, thank you for today's stream. I'm sorry that it's like shorter, but I think our beginner streams will be shorter, cause yes, exactly. Cause, well, why do you want it to be larger than any largest AI? Cause if it would be a multiple of some AI, then if it would be if some AI would equal to our modulo times k. So if it would be a divisor of some of our AIs, then, well, this AI would be equal to 0. And it would really, well, every multiple of this AI would be equal to 0, so it would destroy everything, right? But if you will pick some big random modulo that will be prime also, then you are assured that it will not be a divisor of any AI. Cause, well, they don't know which modulo would you pick. So they will not give the tests that will just destroy your program, right? They don't know what modulo will you pick. So do you understand it? That the only reason you are picking normally, well, larger than largest AI is so that it won't be a divisor, right? You don't want your modulo to be a divisor of some AI. That's nice that you understand. So thank you for this stream. This is probably how our beginner streams will look normally. I think it was much better than my last stream. I think it was good quality stream. So, well, I think it's good to watch those streams. So see you on next stream. And bye. There will also be some explanations to Codeforces rounds and other Atcoder rounds. So subscribe to the channel, give a like, and see you next time.